Hi everyone, this is Mr. Chang. We're doing lesson 3 in exponents. Today's topic is integral exponent. Integral means integer, which means you're dealing with negative number as well. Integer can include negative number. So the topic is negative exponent. So what do we do when we have negative exponent? And what does it mean, right? What does it mean 10 to the power of negative 1, 10 to the power of negative 2? So we'll look at the patterns here, and we'll try to figure out what would they equal to. And you'll see that is consistent with all the exponent law we have so far. Okay, look at the list here. Okay, 10 to the power of 3 is 1,000, 10 to the power of 2 is 100, 10 to 1 is 10, 10 to the power of 0 we know that is 1. Well, how about 10 to negative 1? If you look at the pattern here, 3, 2, 1, 0, negative 1, negative 2 is going down. And then here, you divide by 10, divide by 10, divide by 10. You just get 10 times smaller. So divide 1 by 10 is 10 over 1 over 10. Divide by 10 is 1 over 100. Divide by 3 is 1 over 1,000. So we can see like 10 to the power of 3 is 1,000 and negative 3 is 1 over 1,000. So negative exponent give you a reciprocal. So that's the result of what you see here. And later on, we'll again see how is it being consistent with the exponent law. All right, so we'll look at some example here. Part B. So negative 10 to the power of negative 7, based on what we see, we know is equal to, now what do they want you to do? They want you to write as a positive exponent, which means they don't want the exponent to be negative, they want it to be positive. So what do? Negative exponent mean reciprocal. So 1 over 10, 7. Okay, you flip it, that's take care of the negative. So after you flip it, the negative become positive. Okay, so that's why that's the case. Here, you flip it. Okay, so what happened? Whenever there's a negative exponent, you can flip it to the bottom, then it's become positive. You have deal with the negative sign. So generally, that's the result. Okay. Now, using exponent law to define the negative exponent. Consider the expression 5, 4 divided by 5, 7. According to the exponent law, so what do? Okay, see here, 5, 7 divided by 5, 7, 5, 4 divided by 5, 7, you subtract the exponent, right? And then you will get 5, negative 3. Well, what does that mean, 5, negative 3? So look at part B here, it will explain. Now, 5 to the power of 4 means 5, 5, 5, 5. 5 to the power of 7 means, if you write them in repeated multiplication, you have 5 multiplied by itself 7 times. And let's cancel out the one that is the same. Now, the entire top is like cancel out. Well, does it become 0? No, it become 1. Okay? It's become 1. The bottom, how many 5 are there? There are 3 of them. 1 over 5, 3. Oh, do you see they are supposed to be the same? This equal to that, and this equal to that. So therefore, they equal to each other. Did you see? When you use exponent law with the minus, you will have this result, which is consistent with what we discovered above. So therefore, that's the rule. Okay, so we'll summarize it in the next page here. Okay. The bottom example, we can also do it here. Let's quickly do this one. Write in positive exponent and then one more step, evaluate. So whenever negative exponent, you put it in the bottom to the power of 1 and then you evaluate to the power of 1 is just 2. Here, you put it in the bottom, you evaluate 3 to the power of 2 is a 9. Here, you put it in the bottom, you evaluate 4 to the power of 3 is a 64. Okay? So the first step is whenever there's a negative exponent, you take the reciprocal, you flip it to the bottom. And then when you do that, it becomes positive exponent. Okay? Okay, so move on. Next page. Negative exponent in the denominator. Well, what if I have 1 over 4 negative 3? What do? It says here, use a calculator to confirm. Basically, if you try it in a calculator, you find out this is equal to 64. You try that in a calculator, it's equal to 64, so they equal to each other. But why? Okay, so I'll write here. I'll keep the 1 over on top. What do you do with 4 minus 3? Well, according to the exponent law, it's become the reciprocal of 3. Look at that, 1 over 1 over. So what's 1 over? Whenever you do 1 over, you flip the whatever is in the bottom. Okay, so you flip this, become 4 over 4 to the power of 3. Another way to think about this is 1 divide by this fraction. How do you divide a fraction? You multiply by the reciprocal, you flip this around. So it's 4, 3. Okay, so generally, this is what you do. This is a summary. Whenever you have a negative exponent, you flip it to the bottom and then become positive exponent. What if the negative exponent is in the bottom? Then you flip it to the top. Okay, so it's become positive on top. Did you see the result? So these two are equal to each other. Okay, whenever there's negative exponent, you take the reciprocal. Top become bottom, bottom become the top. Okay, so we have the following example here. So let's try a few. They say express in positive exponent, so they don't want negative exponent, and then evaluate without using a calculator. You multiply powers, you add them. Okay, so you don't need to flip this now, you can just add them. Okay, you add them. 5 plus negative 3, that's positive 2. So 4, 2. So this gives me 16. The second part is evaluate. Okay. Here, multiply, you add the exponent. You add them. 2 plus negative 5 is negative 3. Now, well, I don't want negative exponent, so I'll write like that. I'll flip it over, right? I'll write like that. Finally, I'll write 1 over 27. You leave it in a fraction, you don't need to put it in decimal because 1 over 27 is a very nice number. But if you put it in a decimal form, it will be very messy. Next one, negative exponent, what do? You flip to the top. So this one, just go to the top. And 2 to the power 5 is 32, okay? Wow, what is this? So there are two ways to do it. You can either flip them. Okay, if you flip them, the bottom one become on top, the top one become in the bottom, and then you subtract them. Okay. Another way is, okay, if you subtract them, 5 minus 7 is negative 2, 6 to the power of negative 2. The other way to do it is just do this directly. Okay, you divide them, you might subtract the exponent. Negative 7 minus negative 5. Minus negative become positive, so negative 7 plus 5 is still negative 2. Do you see either way? You get the same result. Of course you get the same result. Now what do you do here? Now you flip this to the bottom. Finally, you have 1 over 36. Okay, so this example could be a bit confusing, so spend your time trying to understand it. Last one, power on power, you multiply them. Negative exponent, you flip to the bottom. Finally, evaluate. Here we go. All right, example number 2. Identify the following as true or false. All right, you divide the powers. What do? You subtract the exponent. 3 minus negative 1. Minus, minus, you add them. Perfect, true. Next one. Well, different numbers. Okay, well, you can, what do you do? Okay, what do you do? Well, you can solve the exponent. Okay, a3, the 4 negative 1 can become on top. Okay, and you put in the calculator, you know it's not the same. This is too big. Okay, so negative exponent just move to the top. Here, well, it's true, right? You just apply the rule, just flip this over. Finally, oh, this is a good one. Now, the negative 3, does it apply to the 9? Does it apply to the 9? The answer is no. If it's meant to apply to the 9, it should have a bracket. So the 9 should remain on top. Okay, the negative will flip the number, only the A. Only A go to the bottom, not the 9. So this one should equal to the 9 remain on top and A goes to the bottom. So it's not like that, so it's false. Okay, this is a good example. Okay, let's move on. So this chapter is not easy when you're dealing with negative exponent. So let's do the following. You multiply, you add the exponent. Okay. and then that's a 7. They want the answer with just positive exponent. You divide them, which means you minus the exponent. Well, first you divide the number. Next, you minus the exponent. Okay? Now, just like the previous example, does the negative 5 apply to the 3? It doesn't. So the 3 remain on top. The x go to the bottom. Okay? So this is a good example. Just take your time to understand this. Next one, the 2 remain in the bottom. 2 remain in the bottom. Sorry, it's in the bottom, right? It doesn't magically move to the other places. And y6 divided by y negative 5, you minus. Y6 minus negative 5 minus negative is positive. 6 plus 5 is 11. Okay, so that's the answer. Another way is to, you can move this to the top, become y5, and then you add to y6, that's y11. Either way, it works. Either way, you got the same result. All right, next one. Negative now apply to everything here. Okay, so what do? The negative mean you flip everything to the bottom, right? This is the first step, right? The negative means flip everything to the bottom. Now you deal with the negative here. You can put the negative in the bottom, right? Cube them is still negative. Usually you don't leave your negative sign in the bottom. The negative sign here means the whole term is negative. You either put it on top or put it in the front. So let's just put it in the front. It just means the term is negative. All right, so what do you do here? A and B are different variable. You don't combine them. So let's work with the number. You have a 2 here. A divided by 2. Well, A5, remember negative means it goes top to the bottom. And here, negative, B, will means go to the top. If it's on the top, go to the bottom. In the bottom is go to the top. All right, finally, here, what do I do? Negative means put this in the bottom. Okay, so the top now, there's nothing there because you put it in the bottom. When you put it in the bottom, you make the exponent positive. So you do it in 2 steps. Do this carefully. Finally, combine the numbers. Oh, sorry. Okay, well, you expand that. Finally, you combine the number. All right. Be very careful here. You need to square the 5 first to get a 25, and then you multiply with 5 to get a 125. Okay, so we're almost done. Simplify and write the answer with positive exponent. Wow, this looks very complicated. Okay, but don't worry. Let's deal with them. Okay, first, there's a division sign. How do you divide a fraction, right? You flip this over. So it's way better if we copy everything and flip everything around. All right. Now, there are 2 ways to do this. You can deal with the negative sign, make it all positive by moving the top to the bottom, bottom to the top. Another way is you can just work with them because you just add them and subtract them and so on. Okay. So I think it may be clear. So let me not use a multiplication sign. We're confused with the x. Let me make every negative exponent positive by switching them. If it's on top, switch it to the bottom. All right. If it's on top, you switch it to the bottom. So this one go to the bottom here, but then the z square remain on top. The 8 x8 remain in the bottom, y3 remain in the bottom, but then the z1 go to the top. Okay, so this is one way to make everything positive. I think is easier to look at. Now divide this, you have a 3 in the bottom. Well, notice it's in the bottom, so it's remain in the bottom. Now let's look at the x. The top, x3, x5, that's x8, and then there's another x8 here. Oh, they all cancel out, right? x8, x8. Now let's look at the z. z2, z1, that's z3, and then z2, z3 minus 3, 2 is z1 on top. So all this become a z on top. All right, finally, how about the y? Well, all the y's is in the bottom, so they remain in the bottom. Okay, you just add all the number a plus 3 plus 3. Here we go. Okay, so this is not an easy example.